Today we'll be deriving integration by parts using the product rule. My name is Jay Krishnan, and let's get started. So the first thing we want to do is we want to recall what is the product rule. So the product rule can be represented as the derivative with respect to x of f of x times g of x. Okay, now just one thing to keep in mind here, if you're already aware of the integration by parts formula, is that it's usually represented in terms of u and v. And same thing with the product rule, but I'm going to put it in terms of f of x and g of x just because it's easier to sort of understand when trying to prove the integration by parts formula. And then after that, we can just substitute u in for f of x and v in for g of x, etc. So anyway, back to recalling the product rule here. So the derivative with respect to x with f of x times g of x will be f of x times g prime of x plus g of x times f prime of x. If you want to know how I got that, or you want to know how this can be derived, one of the ways it can be derived, I have a video on that using logarithmic differentiation to actually get the product rule. Alright, anyway, the next step is to actually take the integral on both sides, the indefinite integral on both sides. Okay, so that's what we're doing here. I'm going to put parentheses here. Okay, so the next step is to literally just take the indefinite integral on both sides. And what you'll notice is that since the integral is also known as the antiderivative or the opposite or reverse of the derivative, we know that the derivative will cancel out with the antiderivative or the integral. So we'll be left with then f of x, g of x, and then I'm going to split this into two separate integrals. I'm going to split this and this into two separate integrals. So then we'll get this equals to the integral of f of x g prime of x dx plus integral of g of x f prime of x dx. So now we've technically derived the formula already, but I just want to put it in terms of u and v and then sort of rearrange it in the way which would most likely make sense or will make sense, because if you're trying to find two separate parts, we want to isolate that, and you'll see what I mean. So look, once we substitute here, so step 3, I'm just going to let u equal to f of x. I'm going to let v equal to g of x, and then du equals to f prime of x dx, and then dv equals to g prime of x dx. Okay? So then the fourth step is to literally just substitute. So just use a different marker here. This is u, right? This is v. This is u. This is dv. This is v. This is du. So I'm just going to rewrite it here for our fourth step. We get uv equals to the integral of u dv plus the integral of v du. So this is correct, but we want to actually isolate the integral of u dv because that actually represents our two parts, and you'll see what I mean in just a second. So our fifth step, I'm going to put therefore the integral of u dv equals to uv minus the integral of v du. So this is our integration by parts. Okay, so the reason why I'm saying we isolate the UDV is, let's just say, let me give a slight example here. Let me use a different color here. Just a slight example. Let's just say we had the integral of x e to the x, indefinite integral of x e to the x, right? So we could just say here that this guy is u, and then this guy is dv. So that's why it would make sense to isolate the u dv, and then to actually evaluate this, we would then go on to the uv minus the integral of vdu, etc. There are going to be a lot of cases where you're going to have to actually do integration by parts within integration by parts. And don't be scared. It's just in that case you'd have to do more work. So yeah, hopefully you now understand where this all comes from, and of course deriving this is really easy. So if you forget integration by parts, you're in an exam and you forget, you didn't memorize this, which is good. You shouldn't memorize this, you should understand it. You are in luck because it is super easy to derive. Just know your product rule. If you don't know your product rule, you can just use logarithmic differentiation, and I will link that video in the description below on deriving the product rule alongside the power rule and the quotient rule using logarithmic differentiation. So yeah, I'll see you in the next video.